In this video, I want to go over the assignment in Chapter 4 for problems 11, 12. For problems 11 and 12, you do need the information in problem 10, and that's what you see in front of you in regard to the Excel spreadsheet where we have YouTube viewers and you have sales. So in this particular case, this particular manufacturer, I believe it was of guitars, believes that sales happens to be dependent upon the number of viewers looking at a particular YouTube video. So what we have here, of course, we have sales, as indicated, is your dependent variable. You have YouTube as your independent variable, or your predicted variable as such. So from the standpoint of looking at the results for problem number 11, I want you to utilize the p-value in regard to indicating if the relationship between sales and YouTube views would be significant, a significant relationship between the two. So from the standpoint that the regression model, the linear regression equation, could be used to forecast sales based upon viewers or those that had viewed this particular YouTube videos as such. So with the results, we have our summary output here, and we have our regression statistics, right? We have the multiple R coefficient of correlation. We have the R square. We have the R square, or the coefficient of determination here, of 59%. So that basically states that 59% of the behavior, the reason why sales go from one level to another, is based upon those that have seen the YouTube videos as such. Then coming back here, analysis of variance, that will be the next problem. That will be problem number 12. But coming down here to the coefficient of that we want to analyze, as we take that into account here, let me just kind of widen out the columns. So for problem number 11, we have the equation, right? In other words, the equation would be sales would be equal to the y-intercept 6 plus the slope. The slope is 0.1 times YouTube. So that would be the linear expression equation. That's what we want to see. Is that equation significant? So what we would do, we would set up our null hypothesis, which we would say the null hypothesis is equal to, or from the standpoint that there is no slope. Once again, when we're looking at the coefficients, when we're focusing in on the significance, we are focusing in on the slope. We're focusing in on 0.1 here. We want to be able to determine, is there a slope? So the null hypothesis, there's no slope. The alternative hypothesis, there is a slope. So if we reject the null hypothesis, we're saying there is a slope. And if there's a slope, then we would say that there's a significant relationship. So in other words, when we look at the p-value for the slope, again, we have 0.0731, or 7.31%. So from the standpoint of the p-value, our statement would say reject the null hypothesis if p is less than alpha, or that level of significance, which I assigned as 5%, which you can see we have a p-value here of 7.31, which is greater than 5%, so we failed to reject. And when we fail to reject the null hypothesis, we're saying there's no slope, there is no relationship, statistically speaking. Therefore, the equation, right, sales is equal to 6 plus 0.1 times YouTube viewers, is not good to use to forecast sales. So the Other problem, problem 12, utilizing once again the data from 10, is our so-called analysis of variance. Analysis of variance. And here I wanted you to use the F-stat in order to make a statistical conclusion. So from the F-stat, in other words, we have degrees of freedom. In other words, if you recall from my previous video looking at the critical value for the F, we have degrees of freedom for numerator and we have degrees of freedom for the denominator. So from the regression standpoint, for the numerator, which is k, which is I've indicated over here. In other words, we have degrees of freedom for the numerator would be the number of independent variables that you have. So that is k. So for the numerator, once again, in degrees of freedom, we have 1 because we have, of course, one independent variable. For the denominator, we have 4 degrees of freedom, which is n minus k minus 1. So 6 minus 1 minus 1, of course, is 4. We look in the table. We look in the table on Appendix D, and we come up with the F-stat, the critical value, happens to be 7.71. So we look at the results for the analysis of variance. In other words, our so-called mean squared regression divided by our mean squared error here of 17.5 divided by 3, we end up with 5.83. So when we look at the conclusion, we would say this: when we're utilizing the F-stat, the statement would be reject the null hypothesis if F, that critical value for F, is greater than that critical value that we found by utilizing the Appendix D, right, degrees of freedoms 1 and 4, we would reject. Now, don't get this confused with the p-value. In other words, the p-value, that so-called reject statement, would be reject the null hypothesis if p is less than our level of significance. Here, when we're utilizing the F-stat, or that F distribution, it's reject the null hypothesis if F is greater than, the calculated value for F is greater than that critical value from the table. So we can see that, okay, our F, the calculated F is 5.83, is not greater than the 7.71. So we would fail to reject, i.e., from the standpoint of our p-value analysis and the F-stat, when we have one independent variable, we will come up with the same response. Once again, look at the significance. Significance of F is 7.31. Look at it for the p-value, 7.31. Let me repeat. When we have one independent, one predictor variable, your significance F and the p-value will always be the same.